All right, so quiz 6. Give the mechanism and products for their action below. So you didn't necessarily have the steps here, but hopefully you had enough to look and say, okay, I have an aldehyde in the secondary amine. Yeah, I've seen these in workshops. What am I going to end up with here? And it's a little different than you've seen, but first of all, protonation. So CH plus got a protonate. Next step's going to be addition. Again, it's an intra-molecular addition, so that's the one little difference here. But again, that will actually make you go faster. So I drew it here kind of ugly because I like to do that sometimes, and then I drew it pretty. I should have put numbers on the carbons, but sometimes it's easier for me to see it see it kind of how I had it drawn before I redraw it. Do a proton transfer. Take the H from the plus charged nitrogen. Do an elimination of the electrons from the nitrogen. Come down, kick out the water. A lot of you maybe stopped here at this kind of iminium stage. It's okay. But ideally, you want to do the last step was the deprotonation elimination. You see that CH, that's alpha. They can fall off. And then you actually make the enamine as the final product. All right, give the mechanism and products for the reaction below. So you're already given, you're making a ketone, so you know where you're going. You're adding an ethyl Grignard. So we did this one's kind of one that fit in a little bit. Ethyl Grignard does an addition. You make this negatively charged imine kind of thing. So it's not really a tetrahedral intermediate, so you can't really do anything else with it. You're not going to add another Grignard because it already has a you can't have a carbon with two negative, like a -2. So at this point you go to step 2 and you protonate. And then you go to step 3 and you protonate some more. And now you've made this even more reactive, so the water can add in. Make a tetrahedral intermediate. You're going to do a proton transfer. Then you're going to do an elimination, kick out the N3 gas. That's what you're going to end up kicking out. And then you do a deprotonation finally to make your final product. Again, driven by gas, but it's a way to turn nitriles into ketones. And so that's a couple different ways, a couple different styles of these things too. And then number 3, fill in the 2 boxes for the products. Recognizing ester and diol H ester turns into an aldehyde, and what's left is this piece from the ester ends up on the aldehyde, or not this piece from the ester ends up in the aluminum, and the H gets transferred here. And we went through the mechanism in other places. I wasn't asking for the mechanism here. It's just the 2 products. You could have done it like this, or you could have drawn them 2 separate ways like this. Either way would have been fine.